Assalamualaikum and hi everyone. Topic 9 differentiation, lecture 3 of 4, part 1 of 3.
Lecture 3 of 4. At the end of the lesson, students should be able to A. Apply the basic rule of differentiation for the following function where u equals to gx is any function of x. So the two type of function that we are going to differentiate is a to the power of gx and the second one e to the power of gx. Okay. For the general exponential function a to the power of fx, where fx is a function of x, the derivative is given as d dx a to the power of fx is equals to, you need to differentiate fx, that is f prime x. You need to multiply by a to the power of fx and multiply with ln a. Okay. So example, differentiate the following with respect to x. If y equals to 5x, y prime equals to 5x multiply with ln 5. B. If y equals to 4 to the power of 3x plus 5, so what is dy dx? Dy dx is equals to 4 to the power of 3x plus 5. Then you need to differentiate 3x plus 5. The answer is 3. Then you need to multiply with ln 4. So I will bring 3 in front. So 3 ln 4 multiply with 4 to the power of 3x plus 5. Okay, we have 3 things to be considered here. There is 3 is a constant, ln 4 is another constant, and this is the exponential function. Okay, what about C? Y equals to 3 to the power of 5 minus 2x. So y prime or dy dx equals to, you need to copy what is the exponential function, 5 minus 2x. Then you need to differentiate 5 minus 2x. The answer is negative 2. Then you need to multiply with ln 3. I will bring negative 2 in front. So the answer is negative 2 ln 3 multiply with 3 to the power of 5 minus 2x. For the general exponential function e to the power of fx, where fx is a linear function, the derivative is given by d dx e to the power of fx equals to, you need to multiply e to the power of fx with the derivative of fx, that is f prime x. I will prove this by using chain rule. If y equals to fx, I will let u as a fx. So y will be e to the power of eu when you let fx as u. So differentiate u with respect to x is du dx. Differentiate f is f prime. By using chain rule, dy dx is given as dy du multiply with du dx. Therefore, dy du is e to the power of u. I will bring dy du here. Multiply with du dx. The answer is f prime x. Then, what is eu? Eu is e to the power of fx. Multiply with f prime. So the conclusion is, when you differentiate any function e to the power of fx, the answer is, you need to copy what is e to the power of fx, then you need to differentiate the function fx, that is f prime x. Okay? Take a look at the first example. If y equals to e to the power of x over 2, So y prime or dy dx is given as e to the power of x over 2. Then differentiate x over 2. The answer is 1 over 2. I will bring 1 over 2 in front. Half of e to the power of x over 2. Okay, B. If y equals to e to the power of 2x minus 1, dy dx is equals to, copy what is the exponential function, e to the power of 2x minus 1. Then you need to differentiate e to the power of 2x. Differentiate 2x minus 1. So, differentiate 2x minus 1. So, differentiate 2x minus 1, the answer is 2. So, 2 times e to the power of, so 2 times e to the power of 2x minus 1 is the answer. Okay, what about C? If y equals to 7 times e to the power of x cubed plus 3x, so dy dx is equals to 7 times the derivative of e to the power of x cubed plus 3x. So the answer is e to the power of x cubed plus 3x. Then you need to differentiate x cubed plus 3x. Differentiate x cubed plus 3x. The answer is 3x squared plus 3. Okay. So simplify, you will get 7 times 3x cubed plus 3, then followed by x cubed plus 3x. Or you can simplify by factorize 3, and the expression in the bracket is x squared plus 1 times e to the power of x cubed plus 3x. So the answer is 21 times x squared plus 1 times e to the power of x cubed plus 3x. X cubed plus 3x. Okay.
Okay, now we move to example 3. Now we want to apply is either by using product rule or quotient rule. So I hope you can apply the rule. Okay, let's do the answer. Okay, A. If y equals to x multiply with e to the power of x, so we can start by let what is x? U. What is e to the power of x? V. So u equals to x. V equals to e to the power of x. U prime equals to 1 differentiate x. V prime or dv dx equals to differentiate ex. Okay. So now differentiate y, dy, dx. So dy dx equals to, actually you can cross here, u v prime. So u is x multiplied with ex plus v ex multiplied with 1. So we factorize e to the power of x, then we have x plus 1. Okay. What about b? We have quotient rule here, because the numerator is u and the denominator is v. Okay, let's say you write first. U equals to 3x plus 1. So u prime equals to 3. Okay. V equals to e to the power of x. So v prime equals to ex also. So differentiate y, dy dx. the formula is v u prime minus u v prime over v squared. So now we substitute into the formula. What is v? Ex. Differentiate u prime 3 minus what is u? 3x plus 2. Differentiate v or v prime ex. Then don't forget to divide by v squared, ax squared. So the answer is, what I can do here is I will factorize ex because we have ex at both term here. So ex, so you factorize ex, so we have 3 here minus 3x plus 2. Remember we have a bracket here over ex squared. So you simplify and you get the answer is ex divide by ex. So the answer, you can cancel out ex. So 3 minus 3 also, oh no, sorry, you cannot cancel. So you have negative 3x. 3 minus 2 is 1 plus 1 over ex. Okay, so this is the simplest form. Okay, we continue example C. If given y equals to 3 over x, multiply with e to the power of e to the power of negative 2x. So you can solve this question by use product rule. This is u and e to the power of negative x is v. Okay, so we write first u equals to 3 over x. I change to 3x to the power of negative 1. So u prime equals to negative 3x to the power of negative 2. Okay, then I simplify to get negative 3 over x squared. Okay, what about v? V equals to e to the power of negative 2x. So v prime is equals to negative 2 times e negative 2x. So differentiate y as usual, dy dx. So the formula is v multiply with u prime. V is e to the power of negative 2x multiply with u prime negative 3 over x squared plus v, you have to multiply with u. V is negative e and negative 2e negative 2x. V prime, sorry, multiply with u 3 over x. So simplify here. You will have firstly we need to factorize because we have the same function here, e to the power of negative 2 at both sides. So e to the power of negative 2x. Then we also have 3 here. We have 3, so you put 3 in front. Then we also have a function of x as a denominator, so we need to over x. So please take note, you have to factorize the same term. Okay, the same term here. So we have 3 for the both of expression here, and we have e to the power of negative 2x, and we have x here. So what is the remaining inside the bracket? The remaining if is we only have negative 1 over x, and for this one, what is the remaining term? We have negative 2. Okay, we only have negative 2. So final answer. So because of we have both term here negative also we can factor out. So we have negative 3x e to the power of negative 2x over x multiply with 1 over x plus 2. So this is the simplest form. Okay. Okay, we'll continue example D. Y equals to ex over ex plus e negative x. So we will use quotient rule here. What is u? U equals to e to the power of x, and v equals to ex plus e to the power of negative x. So what is u prime? Differentiate ex, differentiate v prime equals to ex. Then you have to bring minus in front because of the rule, minus e negative x. So dy dx equals to v multiplied by u prime. So ex plus e negative x, you have to multiply with u prime ex, then minus u v prime. U is ex, v prime is ex minus e negative x. Then divide by u squared, ex plus e negative x squared. So the answer is, you need to expand this. Ex multiplied by ex, e 2x. Ex multiplied with e negative x, e to the power of 0. E to the power of 0 is 1. So plus 1. This one minus e to the power of 2x and plus 1 over ex plus e negative x squared. Then you can cancel out e to the power of 2x. So the answer is 2 over ex plus e negative x squared. Okay, let's continue e. Y equals to 2 to the power of 2 to the power of x cubed multiplied with ln x. So recall the formula for logarithmic function, exponential function. Y equals to a to the power of fx. Okay, so y prime equals to a to the power of fx multiply with f prime x. You need to differentiate f prime x, then multiply with ln a. So we will use this rule now. Okay, so fx is x cubed multiply with ln x. So y prime is equals to, copy the function 2 to the power of x cubed multiply with ln x. Then you need to multiply with f prime x, or you can multiply with ln 2 first, either one. So multiply with ln 2, then differentiate x cubed ln x. Okay, so 2x cubed ln x multiply with ln 2, and you need to differentiate this function by using quotient rule. So I will do straight here. Different u v prime plus vu prime. So copy x cubed, differentiate v prime, differentiate ln x. Okay, you haven't done yet, but I will share with you. If v equals to ln x, v prime equals to 1 over x. Okay, and if u equals to x cubed, u prime equals to 3x squared. So u v prime is differentiate ln x, 1 over x, plus copy paste ln x, v differentiate x cubed, we have 3x squared. Okay, so this is actually the answer, but you have to simplify this one first. So the answer is 2x cubed multiplied with ln x, first term. Second term we have ln 2, and last one we have x cubed over x is x squared plus we have ln x here, 3x squared added right in front, then followed by ln x. You cannot multiply these two at least this one, 3x squared plus ln x. Okay, so this is the simplest form where we have three expressions here. Okay, so thank you.